Hello, everybody. Delighted to be with you this afternoon. Thank you for joining us for this research update webinar. I'm Bertrand Hammond. I'm ambassador at Campden BRI, and I'm also part of the IFT British section. And I've been involved with IFT for many years, as well as of IFST. This afternoon, or today, depending where you are, we have the pleasure of welcoming. Oh, sorry, I've got a fire alarm going. Oh, that's it. Yeah. I've got a fire alarm.
Oh,
sorry, can you hear that?
Yes. Bertrand, we've just had a comment through asking if we can just speak a little bit slower.
Yes, I've just seen that. Yeah, thank you.
Yeah, sorry, I talked too fast. Sorry.
No. Delighted to be with you today. So my pleasure to introduce the three finalists of the Campden BRI IFTSA Graduate Video Research Competition. So the finalists this year are Kristin, Pratiksha, and Kriza, and they will each do a presentation where they will be showcasing their 3-minute video and then give us an update on their research project. The graduate research video competition was set up over 10 years ago to provide an opportunity for researchers, PhDs and masters, to showcase their research, and by producing a 3-minute video, there's fun and engaging for people to really get and understand why they're doing this research. And as part of the prize, the winner gets to come over to the UK for a 10-day study tour, which includes visit to Campden BRI, but also to meet a number of people who are researching the same area as they are, so they can build their network across the research sector, and also get to know the European food industry. So without further ado, I'm going to introduce the first person. So the first person is Kristin. So Kristin Cheng from Chapman Food Science Program. So Kristin, if you want to start with your video and then your presentation. Thank you very much.
Excellent. Thank you, Bertrand. And thank you to IFT British section and also IFST Future Scientists for giving me this opportunity, and everyone for tuning in. As Bertrand mentioned, I was part of Chapman University's Food Science program, and I recently graduated this past May. But during my time there, I was a part of Dr. John Micklebrook's research group, where I did research that combined both food science and also my background in clinical nutrition. And so I'm excited to be able to share part of that research with you all today. So I'll go ahead and share my video.
Did you know that some families are advised to stop breastfeeding their babies with human milk? Human milk feeding is the gold standard for newborn nutrition. But let me tell you about one condition where this is not the case. Chylothorax is a condition where fluid builds up within the chest cavity because of injury, inflammation, or complications after surgery. It affects about 1 in 10,000 live births and between 1 to 9% of newborns with heart defects after surgery. If left untreated, chylothorax can lead to fatal complications. Currently for these babies, standard infant formula is replaced with a specialty infant formula because the presence of fat can result in complications. Now, the downside to this is that these babies are now missing out on all the beneficial components of human milk, such as those that support growth, development, and the immune system. So what can we do about this? Well, one solution is to modify human milk by reducing the fat content, which some clinics have started doing. However, there is still a gap in understanding how much vitamins and minerals decrease through this milk skimming process. This is necessary to understand because vitamins and minerals are crucial in infant development. What if we're currently not giving enough? My research study analyzes the full nutrient content of human milk across 4 methods of fat separation. Aside from centrifugation, which is the standard fat separation method, I also explored a cream separator and manual separation as alternative methods. These methods are not only more affordable, but also easily accessible at home. This means that if they are comparable, the baby can continue receiving optimal nutrition even after they leave the hospital. Our results indicated that all 4 defatting methods led to lower amounts of total fat and would be appropriate to give for babies with chylothorax. Additionally, fat-soluble vitamins, total folate, iodine, and zinc levels were also found to be lower in all defatting method groups. This is crucial to understand because these nutrients play key roles in supporting infant brain health, growth, and development. Ultimately, this research leads to 3 impactful findings. First, we now know how much micronutrients to supplement skimmed human milk to meet the baby's needs. Secondly, this research informs clinical practice guidelines and enhances diet treatment for newborns with chylothorax, which can otherwise be potentially fatal. There will also be global impact as these findings can be implemented in practices worldwide. Lastly, enabling human milk feeding for babies with chylothorax will improve patient healthcare outcomes in numerous ways, such as improved growth and development, decreased readmission rates, decreased gut infections, and an overall increased quality of life. Thank you for watching this video.
Now on to some research updates. I first wanted to start by sharing some photos of what the research looked like. And so these were the human milk samples that were all pulled together. And then these are the experimental groups, which included the centrifuge, nanoseparation, and cream separator. The bottom left illustrates the samples and what they look like after centrifugation. And then this was a syringe and NG2 method that was used to remove the skim milk layer. And then lastly, on the bottom right, there's a comparison of the skim milk, which is in the liquid jug, versus the fat layer, which is in a centrifuge tube. After completing my research, my next goal was to explore ways to translate these findings into clinical practice. Prior to and during my time in my graduate studies, I worked as a pediatric dietitian at CHOP, which is a pediatric hospital in Orange County, California, and I specialize in metabolic disorders. For other than chylothorax, which we saw in the video, this research also impacts newborns with severe forms of very long-chain Acyl-CoA dehydrogenase deficiency, and these are patients that I see in clinic. And this is a disorder in inborn areas of metabolism that affects fatty acid oxidation. It impacts the initial step of mitochondrial beta oxidation of fatty acid, which is how long-chain fatty acids are broken down into shorter ones. This disorder affects 1 in 30,000 to 1 in 100,000 births, and the toxic metabolites that build up can cause damage to the heart, liver, and muscular tissues. Historically, these patients have needed to be on a commercial MCT or medium-chain triglyceride-based formula, but being able to provide skimmed human milk feeding for these patients can improve healthcare outcomes. So what's been exciting so far is that practitioners from other clinics have started to reach out after finding this research abstract through my university's library database. And that's because they're looking to start skimmed human milk feeding for their babies with BICAT deficiency. I've also submitted these findings to a journal, a nutrition journal, and I'm currently in the review process. So looking forward to being able to share the full findings with others soon. And lastly, being able to conduct this research has just been really meaningful for me. And I'm really grateful to be able to do this work. And I'm hopeful that these findings will be impactful for clinical practice guidelines in the future. So thank you all for listening, and I'm happy to answer any questions on that.
Thank you very much, Kristin, for sharing your video and also for giving us an update of where you are with the research. We've got a couple of minutes for one question or two, if we have some from the audience or from the other panelists. Anybody has a question for Kristin?
I've got one.
Yes, sure, Joanna.
I would just ask, hi, Kristin, your research looks really, really interesting. I was just wondering, what would you say was your biggest challenge that you faced? Because obviously research always has challenges, and how did you overcome it, I guess?
Yeah, I think there were a few challenges. One main challenge was interpreting the results. They were unexpected, I hypothesized that like fat-soluble vitamins and choline would decrease. Fat-soluble vitamins because they're connected to the fat, and then choline because it's both fat and water soluble. But some of the results I found were different. Like I found that total folate, iodine, and zinc decrease. And then I found that the choline actually increased in some of the experimental groups, which I think is due to processing. So being able to interpret those results were challenging and figuring out why those became the case. And then also thinking about how I want to translate this. Like it's great that we have this information, but how do we want to use this in practice? So looking at like what is available right now, what vitamins and minerals, sounds that clear. What vitamins and minerals we currently use in practice, and like what additional ones we have to use. That was an additional challenge. But it's an interesting challenge and a meaningful one. So hopefully it'll come to fruition.
Cool. Thank you.
Thank you, Joanna. Any more for Kristin? We will have time at the end to have a broader Q&A, but any burning questions? I can't see any. No? Well, Kristin, thank you so much. Obviously, you're staying with us, so if there are some more questions, you will be here. Thank you. Next up is Pratiksha. Hello, Pratiksha. So Pratiksha is from Louisiana State University, School of Nutrition and Food Sciences. Do you want to take it away?
Yeah, thank you, Bhutan. I have my introduction in the slide itself, and the slide itself is followed by the presentation. So allow me to share my video.
Thank you.
Food is not truly food unless it is safe. Even so, food safety is not always guaranteed. Among various food categories, low-moisture food are underestimated for microbial risk due to their low water activity. However, past cases of product recalls, illnesses, and outbreaks linked to low-moisture foods highlight the urgent need for greater attention to their safety. In particular, packaged nuts require critical attention as they are consumed directly without further processing. Salmonella, enterica, and Listeria monocytogenes are the major foodborne pathogens associated with packaged nuts. They can survive for extended period even under low water activity and refrigerated conditions. Despite stringent hygiene practices in food industries, post-processing contamination by these pathogens still persists, demanding smarter solutions. At the same time, consumers are demanding clean labels and natural ingredients for their food and food preservation, raising the bar for safer, sustainable solutions.
Hello, my name is Pratiksha Shrestha. I'm a PhD student at Louisiana State University in Dr. Farrell's Food Safety and Microbiology Lab.
Let me walk you through our research. Pecan is Louisiana's native nut. Shelled pecans are widely sold as ready-to-eat packaged snacks. That is why our research focused to enhance the safety of packaged nuts like pecans. We created nanocomposite film matrix principally made of lignocellulosic nanofibers. To achieve broad-spectrum antimicrobial effect, we added niacin and oregano essential oil. All the ingredients used in packaging nanocomposites are biodegradable, non-toxic, FDA approved, and generally recognized as safe. Unlike conventional approaches, our antimicrobial film is designed to be placed inside the package directly in contact with the food. This approach will help inhibiting pathogens in ready-to-eat packaged nuts that might have gone under cross-contamination after processing. The outer packaging serves to retain the essential oil inside the packaging, which maximizes the antimicrobial effect within the sealed environment. For validating the effectiveness of the film, we punched the film into 9 mm disc and tested against different outbreak strains of Salmonella and Listeria. The results showed films were effective in inhibiting both Salmonella and Listeria. Zone of inhibition was achieved as high as 19.5 mm for Salmonella and 25.5 mm for Listeria. We also evaluated physical characteristics of the film, ensuring reproducibility and integrity of each batch. These results show our film is not only effective and sustainable, but also scalable for industrial applications.
Thank you for watching this video. If you have any questions, please feel free to contact me at the link provided.
Food is not food.
Now, building upon my research video, I'm presenting a brief overview of my research on developing antibacterial nanocomposite film for low moisture food. I'll walk you over the completed research experiment so far, the research on progress, and the key takeaway from my research findings. To begin, I developed antibacterial composite films using solution casting methods. 3 different film formulations were produced of varying oil concentrations of 0.5%, 1%, and 1.5% respectively. The antibacterial activity of these films were found to increase with increase in essential oil concentrations. The films were also tested against different serovars of Listeria and Salmonella, and Listeria was found to be more susceptible to antibacterial film as compared to Salmonella. Increasing the essential oil concentration also increased the film thickness and film weight, but it increased the lightness of the film, making the film darker in appearance. Therefore, we choose the film formulation with 1% concentration of the oil as optimal for packaging. Now I am doing a challenge study where the fresh pecans are inoculated with the Salmonella and Listeria and packaged in self-standing pouch containing antimicrobial films. The packaged pecans are then stored at controlled conditions, mimicking or simulating the grocery storage, and they are tested for Salmonella and Listeria at control time. The results so far are promising, showing 1 to 1.5 log reductions of the pathogens. Alongside, I'm also analyzing the moisture content and water activity of the pecans throughout their storage conditions to see the relationship between water activity and Salmonella or pathogens survival throughout their storage in the pecans. To deeply understand and also validate the integration of antimicrobials in the films, I'm also doing SEM, XRD, and FTIR analysis of my films. And since the films, antibacterial films have notable aroma that may impart the flavor, alter the flavor of the pecans, I'm also planning for sensory analysis of the packaged pecans with these antibacterial films. The key takeaway from my research finding is that an antibacterial nanocomposite film is shown to prove promising for preventing post-process contaminations for low moisture foods. And for all these findings and accomplishment, I would like to thank my advisor, Dr. Karuna Kharel, my team members and lab mates for their continued support. Thank you all for your time and attention. I would like to answer any questions.
Thank you very much, Pratiksha, and for the video and also for the update. And remind us, how long do you have left in on your research?
I'm trying I am planning to start the related research in next 6 months. So in coming 6 months, I'm hopeful that I will complete all the research regarding this antibacterial films.
And in terms of the interest from industry, have you how's that been? Have you had many interest, or what's happening there?
So far, I haven't came across the industry persons about the interest in the film. The only exposure I got about focusing my research was the IFT, where I showcased my research.
Yes.
I'm hopeful that in next coming years, where I will be not just showcasing as a graduate research video, but also presenting as a paper presentation. Maybe that will give more impact of my research to the industries people, and yeah.
And also applications for other nuts, maybe apart from pecan nuts. Yeah.
Yeah. So my target is currently I'm working for the pecans, but these films are designed for the low moisture food, so can be applied for any other nuts.
Yeah,
Nuts or the powders.
Yes,
and
many
the
applications.
seasonings.
Yeah,
Yeah.
many applications. Yeah, a lot of
Yeah.
people are very interested in the impact of this. Do we
Mhm.
have any questions for Pratiksha? Yep, Robin.
Yeah, just fantastic presentation and really great video, really good production quality of the video, and really kind of explained it well. So you should be really proud of that. I guess, yeah, my question was, are there any competitor products? Are there technology? Is that technology used in other products? I may have missed that at the beginning. And are you able to kind of patent that technology for use in nuts?
Yeah. Very good questions. So far in the market, I have seen that in the meat packaging, so for the high moisture content food packaging, where the antibacterial substances can get in direct contact with the food and can easily release the antibacterial substances in the food matrix, such as in meat, fish, and the sausages. There are antibacterial package applied that works as absorbent and as also for the releasing the antimicrobials. There are very many researchers on this food, but I haven't came across any of the research or the product on the market that applies for the low moisture food.
I see we have one question in the chat from Mohammed, who's asking about in the lab. He didn't see you wearing a mask or hairnet to cover hair. I don't know whether it was required in your particular lab. I know all labs have got different practices. So he was curious to see. Do you have an answer for that?
Yeah. Very good questions. And thank you for your so deeply, minutely attention to those videos. Yeah, for our the lab I'm working here is a PSL2 lab, biosafety level 2. And when I asked with the lab inspectors, they said like if you are comfortable and you are confident that you are doing the safe practice, so you don't have to wear the hairnet or the mask all the time. That is not that is good if you can do it, but if you are confident, or if you are following the other safe practices, that's mask and hairnet are must do. Thank you for your questions.
I also have a question from Harini saying, you mentioned about the use of a lighter antimicrobial film. Can you please elaborate on that?
Oh, the lighter means light in the color sense. For example, in our research, I found that we were preparing different films of different concentration in the first phase, 0.5%, 1%, and 1.5%. And as we increase the concentration of the oil, the color of the film, the lightness decreases. That means the film turns darker in color as we increase the antimicrobial essential oil content. That was the light means the color, indicating the color. LAB, the lightness.
Yeah. Good. Mohammed is still very concerned that you may have some cross-contamination. So perhaps you can have a conversation with him in the chat. Thank you so much, Pratiksha. We're now turning to Kriza. Kriza is from the University of Tennessee Food Science Department. And she's also the winner of the 2025 competition. No pressure.
Thank you, Bertrand. I will share my video.
Yes.
Have you ever consumed a probiotic food or drink and wondered if it actually worked? The probiotics we buy may be known to support gut health, but do these good bacteria really make it to where they are needed? Probiotics are live, beneficial microorganisms that help keep our digestive system in balance. But here's the problem. Many of them don't survive the journey to reach the colon. Our stomach is highly acidic, which can be bad for probiotic cells. Bile acids and salts can also be harmful to them. And even before we consume probiotic products,
these bacteria can already reduce in number due to heat, moisture, or oxygen during storage. That's why there's a need to protect these microbes through encapsulation, so they can survive the journey and confer health benefits.
Hi, I am Kriza, and I am a PhD student at the University of Tennessee, Knoxville.
I am working in the Food Microbiology Laboratory, where I focus on probiotic encapsulation technologies, and I am supervised by Dr. Chishin Zong. My research centers around shellac as an encapsulating material for Lactobacillus bulgaricus, a model probiotic strain used in yogurt production. Shellac is a natural resin with generally recognized as safe status. It is enteric or insoluble in acid but soluble in base. Shellac can therefore protect probiotics from the stomach acid, but it dissolves once it reaches the intestines, making sure the probiotics are delivered to the target. In one approach, shellac, zein, and alginate were used to fabricate microcapsules, which survived better during simulated digestion compared to unencapsulated cells. Encapsulation was driven by hydrogen bonding, electrostatic interactions, and hydrophobic forces. Further exploration of these techniques may yield promising outcomes for incorporating probiotics into yogurt and other low pH food and beverages. The long-term goal of my research is to enhance colon-targeted probiotic delivery.
We consume probiotic products for our health, but without protection, many of these bacteria do not survive the trip. Shellac can change that so we get the real benefits. Thank you so much for watching, and please do not hesitate to reach out if you have questions.
Thank you for watching the video. I'll now share some updates about my research. So my dissertation is on shellac-based encapsulation for targeted probiotic delivery. And as mentioned in my video, I am exploring the encapsulation of probiotics to make them more viable when they are exposed to environmental stresses during processing, storage, and digestion. And to do that, I am exploring two approaches. The first one is microgel formation. So here in the lab, I form tiny gel capsules which entrap probiotics, and the other technique is spray drying. So spray drying is a process of producing stable probiotic powders. And as mentioned in the video, I explored combinations of shellac with zein and alginate to form microgels. And this was just recently published in the International Journal of Biological Macromolecules. Here, we found that capsules fabricated at pH 4.5 had at least 5 log CFU per gram of viable cells after simulated digestion. So this is very promising, and this work supports the shellac-based delivery of probiotics into functional foods. What I am doing currently is spray drying. So spray drying is a common probiotic encapsulation technique. It is relatively low cost and it is industrially scalable. So for this approach, I am trying different combinations of shellac and casein, which is the main protein found in milk. So these are photos of just some of the powders that I have produced through spray drying, and we are hypothesizing that these shellac casein matrices will protect probiotics during spray drying. So the main stress is the high temperature during spray drying, and then these probiotics will further be exposed to the low pH and the bile in the intestines, which can be detrimental to them. So with encapsulation in shellac casein, we want the probiotics to be more viable, and that is what we found, that probiotics survive better in shellac-casein matrix after simulated digestion compared to unencapsulated cells. For this research, I am also measuring the physicochemical properties of the powders, and part of that is the wettability, and I found good wettability. So that is important because eventually we want to incorporate these probiotic spray-dried powders into a different probiotic food and beverage products. So I would be happy to share these results with you in the future. I am targeting to graduate in spring next year, so I hope to finish on time, and I will be glad to answer some questions. Thank you.
Thank you very much, Kriza. So we have a question for you here from Grace. She says, fascinating, Kriza, and congratulations. What is the label declaration of the ingredient in the EU versus the US, and have you tested them in various end products?
Yeah, thank you. Oh, you mean for shellac?
I guess so, yes.
Okay. Right, yeah. Shellac is generally recognized as safe. It is normally used to coat fruits, and it is normally used in candies. So it has been applied in different food products already. I am not very familiar with the EU regulations, but it is already widely used in food, although it has not yet been well explored for encapsulating probiotics, which is what I am doing. And I am still about to test them in actual food products. So what I am doing right now is to develop the encapsulated probiotics and then eventually test them in a real food matrix. I hope that answers the question.
She's yes, thank you. She's very excited for you. Gunnar is saying, wonderful video and work you've done. What will be the allergic reaction to the shellac casein for milk protein allergy?
That is an interesting question. I don't think I will be testing the potential allergic reactions, but for these encapsulation matrices, I am using micellar casein, and it's just a very small amount. Just it's I'm not very familiar with the amount that would trigger allergic reactions, but so far with my preliminary experiments, it's not a whole lot. I am just using a low percentage, but that will be something that is to be explored in the future. Thanks for the question.
Thank you. Any more questions for Kriza? We can pick up some more questions later, but yeah, I think they're the ones for now. So thank you very much again, Kriza, and look forward to seeing you in the UK next year. So you would have graduated by then, yes. Oh, you would have finished, yes. Ooh.
Yes.
Very good. So thank you so much, Kristin, Pratiksha, and Kriza. So we're now moving on to the IFST side, and Robin, take it away.
Fantastic. Thank you, Bertrand. I'll just share my screen with my slides. So yes, really great to see you all on the webinar today, and really great to hear from the other competition that's presenting today. So it's for me to introduce Future Scientist, previously called Young Scientist, which is an annual competition for undergraduate and master's students to present their currently or recently completed research project. So this is a UK-based competition, and participants have the opportunity to present in front of an audience and a panel of food professionals. So applicants are required to submit an abstract of no longer than 250 words on their current work or recently completed project. And these entries are judged and shortlisted. If you're selected, there's 4 regional finals across the UK, and you have 5 minutes to present your research, followed by 5 minutes of Q&A from the panel. And applicants are invited to present their research, which is judged on scientific quality, originality, innovation, industrial application, and effective communication skills. And there's a cash prize and we have one of our winners today, Joanne, who you can see on the left, Joanna on the left, who won the South of England competition. So the competition is sponsored by Pladis Global and PepsiCo, who I'm sure you're all aware of. We were supposed to have Moses here today. So Moses won the North of England and Scotland final. Moses was going to present his project, which was improving the mechanical properties of pea protein biofilms using ultrasonification and heat treatment. He's from Teesside University, but is unable to attend today. This is a picture of him with the judges at the competition, so judges from across industry and academia. And these are the other competitors in the North of England and Scotland competition. But we do have Joanna here today. So Joanna is from the University of Reading, which is also in the UK. And she presented her project, which is called Maillard-derived odorants as a strategy to reduce salt content in foods, evaluation of saltiness perceptions in wheat bread. And we've got the opportunity to hear her presentation again today. So this is a picture of Joanna with her with the judges. So we have judges from PepsiCo, the Food and Drink Federation in the UK, and a ingredient sourcing manager from Innocent Drinks, which makes smoothies in the UK. So big congratulations to Joanna. This is the other finalists who also presented from different universities. And yeah, we're lucky enough to be able to hear Joanna's presentation again today. So I'll hand over to you, Joanna.
Thanks, Robin, for that introduction. So yeah, I'll just share my screen up for you guys, and then of course, if you have any questions, just let me know at the end. Here we are. Let me just put it on actual beginning. Okay, can everyone see that? Okay, it's coming up on my screen. I just want to check before I start.
Yeah, we can see that perfectly.
Cool. Okay, so hi everyone. Welcome to my research where I looked at Maillard-derived volatiles to reduce salt in bread. So before we actually begin, what are Maillard-derived volatiles? So I'm sure many of you are aware, but when you cook food products, something called the Maillard reaction occurs. And this is really important because it's responsible for the aroma, taste, and color of many food products. And so essentially in this context, Maillard-derived volatiles basically mean the aromas that will be formed from the Maillard reaction. And so now we've clarified that, why do we actually need to reduce our salt content in the first place? So we actually need salt in our diet in small amounts, and this is because it's important for things like muscle contraction. However, too much salt has been linked with causing high blood pressure, which in turn can increase the risk of cardiovascular diseases. And in the UK, we're actually consuming 40% more than the recommended salt intake of 6 grams a day. So it's quite a big difference, almost 50%. And with 75% of that extra salt added during food manufacturing, it really highlights the impact that food manufacturers have on public health. So what are the current strategies? There are some things that are being done, including things like salt replacers, flavor enhancers, and different types of processing technology. But for various reasons, including things like cost and off flavors, these aren't commercial to use on a mass scale with different types of food products. So what could be the solution? Odor-induced saltiness enhancement. So odor-induced saltiness enhancement is quite a new upcoming phenomenon. And essentially what it is, it's just a process, it's learned for a process known as associative learning. And it's learned over time. And what happens is an aroma that is found in a salty food product over time becomes associated with saltiness. And so you can actually increase the saltiness perception without any extra addition for salt, which I know sounds too good to be true. However, it has worked in existing research. And some existing research that I found includes salty solutions, nachos, and also a cheese sample similar to mozzarella. So what I did is I decided to add 4 aromas that have been found in these studies to bread dough. I then confirmed that these aromas had retained in the bread through solid phase microextraction, gas chromatography, mass spectrometry. And finally, I conducted testing with consumers to see if they could actually see the difference from the control. And just for reference, these are the aromas that I used, the ones that were quoted in the literature. So the consumer testing was split into 3 rounds, and the first round had nose clips on and the second 2 rounds had nose clips off. And the first 2 rounds had a salt level of 0.92%, which is in line with the average salt content for white bread in the UK. And round 3 had a reduced salt content in line with the latest government salt targets to see if it could get to that level and work at a lower salt level as well. And like I mentioned, it's in the structure of a 2 IFST test, so they simply had to pick which one was saltier. So it was hypothesized that there will be no influence of odor-induced saltiness enhancement with nose clips on, but without the nose clips, people would be able to actually smell the aroma, and therefore they would perceive that bread as saltier. So what were the results? Unfortunately, my results were not statistically significant, even though more people picked the aroma-containing bread as saltier with nose clips on. It could have been down to pure chance. So what can we learn from this, and why could this been the reason? So research has shown that a high salt content actually decreases the efficiency of odor-induced saltiness enhancement. And so it may have just been that the salt content was too high to have an effect. Next, the food structure. The research that has shown these effects of odor-induced saltiness enhancement was in completely different matrices. And research has shown that the food structure can have an effect on retaining aromas. Specifically in bread, you can form things known as amylose inclusion complexes, which actually retain the aroma. And so it may be that there needs to be more of that to perceive that aroma, which then links on to my next point about the dosages. Research has never done these aromas in bread before, and say it may have simply been that the dosages were not high enough to have an effect in this matrix. And finally, not screening participants. The participants were not screened beforehand, and so any inabilities with their sense of taste or smell was dismissed. Thank you very much for listening, and I now open up the floor to any questions that you may have. Just stop sharing.
Thank you so much, Joanna. So if anyone has any questions, do pop them in the chat, and we will ask those questions. I guess just a question, obviously you've just finished your BSc in food science at University of Reading. What are your plans now post-graduation? Are you going to work in industry, or what would you like to do?
Yeah, so to be honest, just searching for work definitely in the food industry. I did a placement year in NPD, so maybe you'd say I'm pushing towards new product development, but I'm open to anything, even if it's quality, sensory, just to really spread my wings into the industry.
Brilliant, thanks. We've got a question from, we've got lots of questions in now. So what are the labelling implications of these compounds being used in food?
Very interesting question. So there is a couple of papers. As I said, it's very new, so not much research is done on it yet. So these products, and pyrazines, the ones that I use, the methanol, are naturally found in food products. And so they're at these sort of safe levels. I think if these were to be taken onto an industrial scale, then it would have to have more research done to see the safety implications at certain dosages. So there definitely could be an implication in regards to labelling, if they would even be allowed to be used at safe levels.
Brilliant. Thanks for your question. We've got another question saying, what an interesting research, Joanna. I was wondering what the criteria for these customers you choose as the panelist to test on the product.
I think you basically mean how did I feel to the participants? I think that's what you mean.
I think so, yeah. How did you select the panel, I think?
So to be honest, it was quite simple criteria. It was things like, they don't smoke, they don't have it, they're not aware that they have any issues of sense or taste or smell. But like I said, it is quite a flawed part of my research. as, you know, they might have not been, because they're not trained panel, they might not be able to tell the subtle differences. And because these aromas were added in quite low doses, they might have not been able to tell the differences as well.
Yeah, that's true. I guess a consideration after looking back. Brilliant. We've got one from Mohammed. Perfect presentation. But did you do your experiment with an apical gluten number or not?
I'm sorry, I don't understand the question. Can you possibly rephrase it? There was gluten in the bread, if that's what it was a gluten, just a normal white bread recipe.
I'm not sure about that. Mohammed, if you could try and rephrase the question, that would be great. I didn't know if any of the other people on the call had any questions. Bertrand?
Actually thinking of, you know, when you're airline food, you know, there's always a challenge when you're in space in the airplane, your sense of tastes are duller, aren't they? So they and then often you end up the recipes for food that is eaten on the plane have more spices or salt or whatever. So I just wondered whether if you could use that to enhance the enjoyment of food in the plane as well, to have these aromas to enhance the saltiness and maybe some other factors. I don't know. That was running through my mind when you were telling your story.
Well, I didn't actually know that. That's quite interesting. I would probably say there's definitely a possibility to do that. I think maybe bread isn't the best matrix just because it is quite a starchy product, but it could definitely be applied to different types of products. I mean, flavor is the combination of aroma and taste. So I could definitely see that working.
I've got another question, which is, I guess you've finished your BSc and now graduated, but if you could continue your research in the field, what would you look at next if you were to continue your research?
I would probably say maybe give bread another go with some higher dosages, and definitely try different products where salt content is very prevalent, to of course hopefully apply that and be able to reduce our salt content.
Brill, I've got another question, but I guess we're opening the floor. Are we now, Bertrand, to...
Yeah, we may as well, yes.
Other questions? So we've got a comment, such an amazing presentation. What did you consider what did you consider the most challenging during the project?
That's a really good question. I would probably say there's two different things. One would say recruiting the participants, because these people weren't getting paid, so people are less likely to want to partake in the study. So that's definitely one, recruiting participants that would be suitable as well. And the second one would definitely be trying to find the right dosages. I mean, the dosages were multiplied from the literature to kind of represent a food matrix. But again, because it's never been done in bread, it wasn't direct. This is definitely the right dose. So I would say that's probably, a big challenge.
Perfect. So I guess we'll open the floor.
Yeah.
Pratiksha,
May I
your
ask one
question?
question?
Yes.
Yeah. Yeah. So when you were doing your research and did your literature review, did you came across the similar research where they have already used the strategy of lowering down the salt content? If so, have they already done in the bread or similar kind of bakery products? Or if not, like, are there these studies applied to other food categories? And if yes, then what categories? I'm so curious.
Yeah, no, good question. So the study that was done that focused on, so essentially it was salty solutions, and they found that when you had a higher salt content, so the lowest salt content of the salty solution from the top of my head was about 0.3%, and then the top was about 1.2%, and they found that gradually, as you increase the salt content, you had a negative correlation with the effectiveness of odor-induced saltiness enhancement, to the point where it actually wasn't significant anymore. And there was no studies done, as I know of, to date, on bread or other sort of starchy foods, just the nachos and the mozzarella cheese. Thank you.
Thank you. Thank you for the answer.
That's all right.
Well, so we've got a couple of minutes left. So if anyone has any questions for any of the presenters today, please pop them in the chat. We've just got a nice comment from one participant saying, congrats to all the presenters, great presentations and projects all round.
That's from Gunnar, who's the next president of IFT. So that's a praise, a good praise. Kriza has a hand up.
Yeah, my question is for Pratiksha. It's a really interesting research. I also do side projects on food safety. Just in relation to your response to Gunnar's question, you said that the films were still effective after 2 months, and that's pretty amazing, I think. I just wanted to ask, like, how many log reductions are there after 2 months, and what is your target, and like how comparable is that to other studies?
Yeah, that is very tricky questions.
Yeah.
Yeah. So so yes, we normally would assume that there will be burst release of the antimicrobials in the first phase and then slow it later on. Some kind of similar is going on in my research. Like I had very high reductions in first few months, and now it is decreasing. But the good thing is it is still working. It is showing greater reduction as compared to the control terms. And I'm hopeful, like previously when we targeted for the a challenge study, we targeted for 1 year, thinking that normally the shelf life of the dry foods is beyond 1 year or nearly 1 year. But like the study is suggesting that as we increase the storage time, even and the storage condition is we chose is the grocery storage conditions, 55 relative humidity and 20 degrees centigrade. So my research finding is suggesting that even the water activity, if you have the suppressed water activity for prolonged time, the bacteria starts to dying off. So I'm hopeful, like I'm not sure like for how long I'm gonna get the results, but I'm hopeful.
Thank you.
Thank you for your questions.
Any more questions? I was just thinking, because listening to Kristin's presentation and Kriza's presentation, whether there was any encapsulation. I don't know, it might be a completely stupid question, whether there are any encapsulation solutions to help with your case, Kristin. You know, the case, I don't know, is that a stupid question?
I think there's definitely there's definitely research that can translate into clinical practice. From Kriza research, when I was listening to your research, Kriza, I just thought a lot about like the GI patients, like the patients that have a lot of like stomach and intestinal issues or IBD, things like that. So I think for those populations, there's definitely a lot of applications in the clinical space too. But yeah, for my patients, I feel like we could use this encapsulation as well. GI covers a ton of patients.
Very good. All right. Any more for anyone?
There's a question in the chat from Harini.
Oh, well done. Where is that? Harini.
It says, you mentioned about the usage of light-coloured antimicrobial film. Why is a dark-coloured film not used?
Oh, okay. Yeah, very good questions. Yeah, I was expecting this, like somebody would ask me, and because 3-minute time was like not sufficient to explain all the things I have done. And I'm so thankful that you raised these questions. Actually, we didn't select the films only based on the color. There were some other graphs I couldn't show that. So here, as we increase the concentration of the oil beyond 1%, we show that with increase in the film thickness and the film weight, the film become like not that much flexible. So for example, if we hold the film, then it would break off easily. So that was the other physical constraints that we considered for selecting the concentration of the film? Thank you for asking.
Right. I think we can wrap up now. So thank you so much again to Kristin, Pratiksha, and Kriza, and to Joanna as well from on the IFST side. So there was a great collaboration between IFT British section and IFST. I think we should do more of these. Rihanna, do you have any parting comments? Where is she?
Sorry. Hi.
Hello.
Just thank you so much for joining, everybody. I'm just going to launch a quick poll question, just to ask if you'd like to hear in more depth about any of the topics that we've heard about today, or any other topics as well, because that very much guides our plans for future webinars. So we'd absolutely love to hear your thoughts on it. And please feel free to get in touch by email anytime as well. So I'm absolutely delighted for everyone to join today. Thank you so much. Thank you.
Thank you.
Thank you all. Thank you, Rihanna,
Thank you
for
all.
coordinating this wonderful meeting.
Thank you for the amazing speakers. You've all been wonderful. Absolutely amazing.